business model, the development of compactness into a hydrogen tank manufacture. And so I will start with the presentation. I think this one. Okay. This picture, I found it's from the former workshop. I started in 1999, and this is a coppersmith. He is working on a form that's making a marzipan, the present, and he is riveting the container. This container has been produced from a flat plate and formed by heating and forming this plate on a negative form. And so this time is working a long time before, but these containers are still in production. And the cost of such container was at that time EW Beetle, that means roughly 13,000 D-Mark at that time. But sorry. So this is our premise actual today, from outside and from inside, and but we are still working with the old craft. For the prerequisite for the transition from the traditional handcraft business to manufacture of hydrogen storage tanks, are various certificates and quality management systems necessary that allows us to manufacture pressure equipment. And in this case, this is the quality management system ISO 3834, that is working with the special requirements of the welding technology. And for the German market, it's the 82000 HPO code of practice. For the American market, we are certified according to Asthma Boiler Pressure Vessel Code, and we are allowed to register the pressure vessels we have manufactured at the national board. For the addition to these certifications, we are the manufacturer. We are allowed to manufacture pressure vessels for the use on ships. That means according to BV and Bureau Veritas from the DNVGL, which is now DNV, and Lloyd Register of Shipping. So if these pressure vessels are used on the vessels, these certifications are necessary. So I will give you some pictures what we have done in the past. This is in 2000 liter production plant with agitator, where the flavors are produced. These flavors are then sent to the tobacco companies, and they buffer these flavors in these small tanks, and then heat it up, and then it will be sprayed over tobacco, so you get the special taste of the cigarette you are smoking. This is a cooling water installation which works in the Max Planck Institute in Greifswald in Wendelstein 7. This is a test facility for plasma physics. So we have a standard pump, we have filtering for filtering the water to deionate, measuring devices which flow. We have the conductivity of the water is measured here in this, and so we have a little one is a test facility for testing pumps of aircraft. In this yellow housing, there are installed the aircraft pumps with kerosene and for pumping kerosene. And then the pumps are tested if they have the right flow. Also, under these special conditions, that the tank is moved and the aircraft is flowing under 45 or 60 degrees. So the engines of the aircraft get the right power from this kerosene. This is another special equipment. I hope this will never act if you are sitting in the aircraft. These small gray parts are plastic parts which are welded by. So this is the heat exchanger, classical heat exchanger on the cruise vessel. Nothing special. It's normal carbon steel, and is producing fresh water on the cruise vessels. The next slide is just normal bended pipes. These are for the food or drinking facilities where we are drinking filling machines. This is for steering the valves. This one is the smaller one is for cleaning of the valves and the system, and this is for the product. So in each connection there will be filled the bottle or the liquid into the bottle. This is a standard titanium ring, and this is in the underwater pumps. This on the head of the pumps. So there is a lot of growing of I don't know. Algae. Thank you. And so the pump decreases, the efficiency of the pump decreases, and then they send a little bit crucial liquid to the pump head, and then it can pump again. So these are special bended pipe. I think it looks very good. I don't know the special the use, but I think it's for compressed air and for steam. I think it looks very nice. So the research and development activities of Schiffmaschinenanlagenbau is two parts. One is the hydrogen technology project. We started already in 2009 to develop different hydrogen storage systems for Herion, at that time GKSS, and they tested and did the research for the hydrogen storage of hydrogen in metal hydrides. And in 2018, we got a partner for the H2 hybrid project. This was a project together with Herion, with Volkswagen, and Pankow is another small medium enterprise where we developed a metal hydride storage system for the mobile application. And in 2019, we get a partner from the ICAP project, where we wanted to store 50 kilogram hydrogen in metal hydrides, only for the stationary application. And in 2021, we have been the manufacturer of the hydrogen storage system of the Zeus project. This is an application of 2 times 20 kilograms of hydrogen for the level application, where the hydrogen has been stored in metal hydrides. On the other hand, we have, because I was always looking for my own product, we became a project partner for etching of glass technology etching glass technology project, etching glass fibers with reducing molten salt. And the aim of this project is nothing to do with hydrogen, it's only part of the Stichwort-Anlagenbau, but I would like to mention it. The aim of the project is to develop the process and the equipment technology for the etching of glass fiber using molten salt. The advantage of this process to previous technology is that you don't get micro cracks on the surface. Correspondingly, you get a defined etch stop because you get out the etching material out of the micro cracks. So you get a much higher stability of the fibers, and that's much smaller diameters are possible. The goal of the etch is etching down to 25 microns, and actually it's 50 microns. This is an investigation of the project partner acceder in Berlin. So we etched down to 50 microns and surface roughness of roughly 95 nanometers. This is the activities we have outsourced to our sister company Amstock, and this is an impression from or picture from the holder of the glass fiber where they are put into the molten salt and etch it. So let's come back to the hydrogen technology. This was the first hydrogen storage tank for the project of Storm. And this is normal stainless steel. I think the working pressure was 100 bar, if I remember right. At 400 degrees centigrade, and I've never heard